We are back for webinar number 4 of the MTConnect Student Challenge webinar series. My name is Steve Miller, better known as Kelly's dad. Thank you for joining us again for the fourth. I think this is the final live webinar that we are doing in the series. And as usual, now like I say, okay, right here, first of all, I should just point out that right over here, right down here, if you look at this and you want to call in right now, if you want to call in right now, you can to this number and listen to us. Otherwise, just keep on listening on your computer. And let me introduce the panel for today's game show. We've got Helena Hailu, who is the brains of the bunch here, right? We got the brains of the bunch, MTConnect Product Manager for the MTConnect Institute. With AMT, the Association for Manufacturing Technology, needs more things. And that is the person at the bottom of the picture, okay? Not the one right directly below me, but that's yes, she's giving a little wave there. And then we are not. See, I corrected the spelling. All right, for Tim Shinbara, who is not here, but I did correct the spelling for Mr. Manufacturing Technology himself, the VP of that for AMT. And then the godfather of MTConnect himself, Will Sobel, who is the Chief Strategy Officer for System Insights Incorporated. Welcome, both of you. Welcome back. Thank you for joining me. Helena, I want you to very quickly, well, here, I'm just going to jump through this thing. You know, sessions are being recorded, submit your questions, and I will give you an updated Facebook thing here. There we go. Okay. Helena, just very quickly, tell us a little bit about the MTConnect Student Challenge and what that's all about. You can see that there's some information to follow up with you right there if they want to. But what is this? This is session 4, but for somebody who might not have seen the first ones, what is this?
The MTConnect Student Challenge is an innovation competition that's sponsored by the Office of Secretary of Defense, Defense-Wide Manufacturing Science and Technology. Steve, it consists of 2 separate, completely separate competitions. The first competition is ideation, and that's where we're asking students to submit a 5-page proposal where they identify a need within the manufacturing industry and propose a solution. Again, 5 pages, and we have new deadlines. We've extended the deadline. The new deadline for that is March 15, 2016.
March 15. If I got it. Let me jump up here to where, there you go. Yes, I did update things.
Okay. The second competition is the application development competition. And that's where we're asking students, again, to identify a need within the manufacturing industry and develop an application, a software application to address the need. The new deadline for that, which has also been extended, is July 15, 2016.
Oh, is it 15? Sorry, I got that wrong.
Yeah.
Sorry.
That's okay. So there are great opportunities for those who are either finalists or winners to engage with industry by participating in this competition. The first opportunity for them to do so is, we're encouraging students to talk to the manufacturers, to interview them for both competitions. Now, we're also inviting these students, specifically the winners of the ideation competition, to MC Squared, which is a digital manufacturing conference. For those who are participating and are finalists in the application competition, we're going to be inviting them to IMTS, the International Manufacturing Technology Show, which is one of the largest trade shows in the world, and they'll be taking in Chicago in September.
Cool, excellent. Let's see, was there a couple of the winners from last time? Valerie was the one who submitted the ideation, right? Or was that the application?
That's correct. Actually, both of them submitted for ideation. Should I go ahead and talk about that?
Yeah, sure. Go ahead.
Okay. So the slide that you're looking at contains two pictures of the top winners last time. Both of them submitted a 5-page proposal for ideation, and neither one of them won for ideation. But they went ahead and developed an application, and Valerie over to the left was a graduate student at Clemson at the time that she won. And Joel Neidig over on the right was, and it still is, working at IPAMCO. He was part of industry, as the last challenge was open to industry. Joel had a solution where he married Google Glass with MTConnect, and his solution was actually very much of interest to companies like GE.
Excellent. Excellent. Now we've already gone through three webinars, and what will essentially, let me, I'm going to go ahead and pull up the where we were, or is this where you wanted to start?
Yeah, or even the
Okay.
previous slide. Let's do the intro slide. 1 second. Let me see if I can grab.
There we go. Yeah.
Oh, sorry, I'm not great. So what can you kind of give me a quick synopsis of what you talked about before? I mean, it's what's on the other three webinars?
Sure. So we gave the first one was more of an industry overview that talked about what the needs are of manufacturing industry with the digital revolution, with Industry 4.0 and next generation manufacturing that's now emergent. Things like industrial Internet of Things and all those trends that we see in the marketplace and how those are going to affect the way we manufacture things, the way the industry is going to shape up in the next, 10, 20 years. The second one, we got deeper into MTConnect and how MTConnect is used to be able to collect data and get data from manufacturing, some of the issues that we have in manufacturing, also some of the blockers, why people can't get data right now because of the old machines and so forth. The third one was on the MTConnect information model. So MTConnect itself provides data from manufacturing equipment, and it's structured, and it's what's called a semantic model, meaning that it provides vocabulary, all the words that describe what's going on in the manufacturing process, both the data that you're getting off the machines, also the structure of the machine, the structure of the cutting tools, and the process flow for the parts. And now we're going to go one level deeper. Now we're going to talk about how do you get the data from what we call the MTConnect agent, which is a little HTTP server that runs somewhere on the network and provides this data to you. So this fourth one is going to dive deep into how you actually interact with MTConnect live. So with that, I will get started with the protocol section. So if you remember back when we were talking before, MTConnect provides both the protocol and the information models. We drew a distinction between different types of standards out there, standards that provide only protocol, things like Ethernet IP, OPC UA, and then standards that provide only information models, things like STEP, the AP 242, 238, and so forth models, and then things like ISO 13399 and ISA 95, which provide cutting tool and process respectively. They provide the structure of the data, but not the way to get it. MTConnect provides a little bit of both, both the structure of how to get the data as well as the way to get it from the network. So what MTConnect provides is basically this concept of agent. The agent is, like almost all HTTP servers right now, a RESTful server. So basically you implement something called REST, which is basically a way to formulate a request from a service given just a URI. There's no real additional information required. And representative state transfer also specifies that the client application is responsible for maintaining state. The server doesn't keep any state about the client specifically. And you'll see how that plays into the way MTConnect works as we go through this. The agent itself is just an HTTP server. You can serve up documents as well as the MTConnect data. It has special extensions to be able to provide the MTConnect protocol, as well as some security extensions that allow it to only serve up very specific documents. So it's not like a general purpose web server, it's a very specific web server. And it provides what's called a store and forward service. So basically, it collects up data internally from various different devices. It can support multiple devices. And then it provides that data out as requested, but it also keeps the buffer. And you'll see how that also provides things like fault tolerance and high availability. It also provides what we call sort of the second concern of manufacturing, which is a key value store. So if you're familiar with things like the NoQL databases, Mongo, Cassandra, any of those things, it also provides the ability to be able to get an entire information model document using a unique key. So we're just talking about the concept of store and forward. The idea is here, and we lost some of our fancy animation when we went to this, but I'll try to use a pointer here. The idea is the adapters, which we're going to talk about in the second section of this, are collecting data continually from the machine. So we went through a little bit of the high level of what the adapters are. They connect up to the machine tool's proprietary API and do what's called a syntactic transformation. They take the data from the machine tool's API and convert it over to the MTConnect vocabulary, basically so taking things like the state or the machine tool mode and turning that into things like controller mode and automatic manual data input and assigning the correct vocabulary, also doing units conversion to things like millimeters for positions, and then setting it over in a very simple pipe delimited key value format. And it just keeps pushing data as fast as it can to the agent. The agent then buffers it up. So it stores it in what we call a circular buffer, which is a fixed size buffer, and it will have a certain amount of backlog. The applications can then request data from the agent, and they will start at wherever they are in this buffer, and then as data gets pushed from the adapter, they'll pull it out. Now, they don't have to be completely synchronous with the data flowing out of the adapter. They can fall a little behind, and they can request data as they need it, and the data will just flow up from the agent to the application. The application can also get what are called push events, and we'll talk a little bit more about that. That's basically where they make a single request to the agent, and the agent then updates them whenever anything changes. So to go a little bit deeper into what we mean by a circular buffer, basically, as events occur, they're pushed into this queue. And here we have like a sample with 8 slots. In normal operation, the default for the agent is 131,000. So the idea is you can actually put enough data into the agent to have, let's say, a day's worth of data. So if you get disconnected, you can pick up exactly where you left off. As the data gets pushed into this buffer, the old data falls off the end. So here we have an empty slots, and as we push A in, it will take the slot number 1. B will take slot number 2. C gets pushed in, and so forth, until we get up to J. That gets pushed off, and A is dropped off at the beginning. If you look at the data will be updated. Now, MTConnect also keeps this idea of the current state at any point in the buffer. So our current right now is equivalent to the latest values for each one of these pieces of data. Here we have X, Y, Z, and there are 5, 12, and 23. That's our current value. We can actually roll back time to any point in history and say, okay, tell me what the current values were at sequence number 29. And these are what are called sequence numbers. Sequence numbers are just a monotonically increasing value that indicates the position in the circular buffer, and it never wraps around. It just keeps increasing forever, and it's in 64, so it can go on for millennia. Using this technique, you can basically say, okay, give me what the current values are at this point, and then give me every single delta past that. If you notice, these are all just changes. So we only keep deltas in MTConnect. So as you move forward in the buffer, as things change, and here like x is now changed to the value of 2. Next one, z is changed to 21, so just as z value changes, you'll just get this delta stream. And that way, you can rebuild the state at any point in time. Now, MTConnect has 3 requests. The probe request, which gives us this device's information model. If you remember back from the previous webinar, we talked a lot about the information models. This describes all the data items and components that are available from the machine. So basically, this will tell you the logical organization of the machine tool, what axes it has, X, Y, Z, C, A, B, Cs, etc., as well as how many controllers, all the controllers, and the number of paths within the controller. We then also have the current, which tells us what the current value is of those data items. So the devices doesn't give any data. It just gives us a structure, just the metadata. The current itself gives us the current value for all of that data. And we can also ask for the current, as we just showed, at any point in the buffer. If you do a current by default, it'll give you the latest values. The next request we have is called the sample. That gives you a time series of values starting at a particular position. We also have the assets, which again are these information models, the key pairs. And the way we usually access data in MTConnect is we first do a probe to find out what data is available for each of the devices. Then we do a current to give us a snapshot at that point. And then we do a series of samples. The samples then give us the deltas from that current. So we can always construct that entire time series of data. The other way we can go is a probe, and then we do a current. And then the alternative version of sample is a sample with what we call an interval. And the interval then pushes data on a real-time basis. So dig a little bit deeper. Remember the information models we went through, so I'm not going to go through the actual structure. But we do the probe. Now the probe gives us the data. So we can get a probe for all devices by just specifying it like this with no device here. And this is actually something you can do if you want to. This URI is always active, agent.mtconnect.org, and you can test this URI directly. We can get all devices, so the agent can support any number of devices. You can even have, we've deployed 50 to 100 devices using the same MTConnect agent. You can also get data from a single device. So if I want to be specific about the device, I can put it right here, and this is my single device, and that's, again, the probe command. Every time you connect up to the agent, you first do this initial probe, you can check what's called the instance ID. You see it's right there in the header of the message. And the instance ID will tell you if the agent has been restarted. Now, every time the agent restarts, there's a chance that somebody may have reconfigured it, either added more devices in or changed the structure of a device. So it's a good idea when you notice, if you're using MTConnect, to do a probe and check to see if the instance ID has changed. If it has changed, what you should do is query for each, do one of these probe requests against each one of the devices to make sure that nothing has changed in the structure of those devices. If the instance ID has not changed, you know that the agent has not been restarted, and therefore this data will always be the same. So once you do your probe and you have all the metadata, you know all the structure of the devices and everything else, the next thing you want to do is do a current. And a current will give you that snapshot of the data. And what you're going to get is one data item value per data item. And we'll get into why that's important. The sample can give you multiple. Current is only going to give you one. It's going to give you that latest value that's known for every single value in the agent. The interesting thing about this is that even if that data is no longer available in the buffer, in other words, it's rolled off the end, the current will still maintain that latest value. So you can always find out what the most recent value is for every single data item, for every device on the in the agent. Now, there's also this special version. So basically, I can also say, give me the current at this position. So if I have a sequence number, and I want to find out what the current value is at that point in time, as long as it's within the circular buffer, I can say, get me the point at that point in history, so I can investigate the data as of some sequence. That allows me to roll back time. If I want to say, okay, at the time the machine changed state from, let's say, just became active, what was it doing at the previous sequence number to that? I can say those kind of questions. If the machine, let's say, has a fault, I want to say, okay, tell me exactly what was happening 10 changes before, 10 data items before, just at that point where it failed. I wanted the loads, I wanted those speeds and feeds. You can do that using this current at semantic. The next one that we have is a sample. And the sample gives you the time sequence, time series of data. So after we do that current, if I wanted to, let's say, I got my current and I want to say, okay, continue on and give me all the deltas from this point forward, what I do is I do a sample from that point. By default, the sample will start from the very first item in the buffer. So if you don't give it any from, as you see here, it will start sending data from that point forward. Otherwise, you can take it from the next sequence. So if I have a current, it'll have the next sequence, and I just start from that next sequence and I roll forward. Every single time I want to get the next chunk of data, I set the from to what we have here in the next sequence. I can also say count. So count by default is 100. If I want to, I can say get me the next 10,000 items or the next 1,000. It will give you up to that number of items that are available from the buffer starting at this value. If there aren't that number, it will give you as many as are available at that point in time and always tell you where you can start next. So to go through a small example, we do a current. The current gives you the next sequence number. We then take this value here and we put it into a sample from this value here, next 1,000. As you can see, the next sequence number is now 1,000 past that, 8116 instead of 7116. We then start at the next sequence and again continue. And when the next sequence is equals to the last sequence plus 1, basically we're off the end of the buffer. That means there's no data available. And you can see that right here. And what you'll get if you make that request is basically an empty stream. So that tells you that you're basically polling at the end of the buffer. It's fine to do that. You can keep doing that. And once data is available, you can just continue on again. So this is what we call poll-based polling, or basically polling the server. As long as the instance ID is the same, basically you can keep polling and polling and polling. If you try to get data and you've fallen too far behind, you'll get what's called an out-of-range error. And that basically means that you need to do another current and resynchronize yourself with the stream. So if you're too slow, if you're not polling fast enough, and the data is being pushed into the agent faster than you can pull, basically you'll start finding yourself falling further and further behind. The other thing you're going to find is that if the instance ID resets, you'll need to start over again as well, because you'll be offhand. Now, by default, MTConnect gives you all the data in a device. So basically, you'll be looking at every single data item in that device. And often, that may not be what you want. You may want to have just a subset of the components in the device. And if you remember back when we talked about the information model and XML and so forth, we talked a little bit of XPath. XPath is how in MTConnect you filter to just the data items that you want. And there's this argument you can pass in the URI, again, which we're all RESTful, so you specify this on the URI just as any other argument, and you put the path in there. And when you specify the device will also limit the expression to just one device. So there'll be the XPath within that one device. So here's an example. If you want to just get, let's say, only the axes data, we'll say path is equal to axes, and that will just give us that one subset of data associated with the axes. We can then say, let's say we only want the position data within that this model. And if we request just the position data, we'll get only one set of data. So basically, we'll just get this one data item here. And if you want to select, let's say, the position or the angles, we'll just get this position data here, or the angle data from the rotary axis. And then if you want to just get the linear x-axis is how you do it. You can put any attribute name in there. We talked a little bit about this earlier. And you just say at name, you put any predicates, you put ands and ors in there. And I'll say, okay, just the linear axis that's named x and the position within that x-axis. Now we talked about the idea of polling for data. That's when you pull data, and again, that's the client's responsibility to poll as fast as possible and to keep the data flowing. The other way that you can use MTConnect is what we call push-based. And this is very similar to, if you're familiar with any of the pub-sub protocols like MQTT, AMQP, or even Redis or anything along that line. They just push data as it's available to the client. Now, MTConnect supports that as well. Again, we're doing, in reality, MTConnect is really a store and forward, publish, subscribe protocol. And the path allows you to subscribe to particular data items, and it's semantic, meaning that you can say position, and that's going to mean the same thing on every single machine tool out there in the world. So with MTConnect, basically, you can lower the amount of overhead. So in other words, you don't have to keep making requests over and over and over again, which is kind of costly. And you can have the agent responsible for telling you whenever anything has changed. Now, if nothing has changed for 10 seconds, it will send you out a heartbeat. That just tells you the MTConnect agent hasn't died yet. And it's using what's called X multi-part replace. X multi-part replace is a standard that is used on the MTConnect standard, and W3C. It's actually used on quite a bit of different services. And it's a little older. There's some new standards out there using WebSockets and Stomp and Redis and so forth that come that stream data, and eventually MTConnect will actually support those in the next version of the agent. So the way you would do this is you specify one thing here. It's called interval. And the interval tells you how often you want the MTConnect agent to push data to you. In this case, I'm telling it to tell me every second all the changes that have occurred over that last second. I can also tell you how large I want it to block data for me, so up to 1,000 items in that document every second. If there are more, it will send me 2 chunks of 1,000 changes. And you can also tell it how often you want it to heartbeat you. So if the 10-second heartbeat is too slow, if you need to, let's say you're doing real-time device integration, you need to find out if the agent has, or the device has failed within, let's say, a second or 2 seconds, you can put the heartbeat here. And it's a good just sort of rule of thumb to have the heartbeat, 2 times heartbeat frequency is a good sort of rule of thumb for detecting failure. So if the agent doesn't get back to you within 4 seconds, you can pretty much assume it's dead. You can also do back pressure. So basically, the MTConnect agent will not hold the data for you infinitely. So if you're not consuming it, TCP/IP, which is the underlying protocol, automatically buffers data. It only buffers up to 8K. So if you're not consuming data quickly enough, MTConnect will cut you off. The agent will not buffer for you infinitely, and it will cut you off. But you have that last point where you dropped off, so you can always pick up where you were dropped off. Look at what it actually looks like. In reality, this is actually a dump of the headers coming out of MTConnect. You have the content type, which is X multi-part replace. It tells you this boundary. The boundary is a unique identifier right here, which tells you the separator between the different chunks of data. And the transfer encoding is what's called chunks. Chunks means that there's going to be a separator. Also, it's kind of hidden in here, but there's 2 bytes of data. This is part of the W3C HTTP standard, which separate each one of these chunks. And so it's sort of doubly encoded. But when you're parsing the data, you'll look for this separator here, which starts with 2 hyphens, and it will tell you the type is always going to be text XML, and then it will tell you the content length, and this is exactly how long that XML document is going to be for this chunk of data. At the end of this document, there'll be a character return line feed, and then another chunk right here. And after each one of these chunks, all the data will fill in here. And basically at the end of that chunk, you'll have another separator and more data will flow. So that's exactly what it's going to look like as it streams over. The nice thing is we'll be streaming data to you on a continuous basis, and you'll just be consuming it. There's open source, and they put these links out at the end of this. There's open source implementations of this which you can just use. And so you don't have to worry about parsing this. We've already done it for you. There's some examples in .NET and Ruby and Python, a whole bunch of different languages, and C, so just use those. The heartbeat itself, every 10 seconds, will come out like this. This tells you that the agent is alive, and you're going to see it's going to be empty streams document. This is actually the exact same reply that you'll get if you request data off the end of the buffer when you're doing the polling version. So you'll just get this empty streams document and say, okay, fine, I know the guys are still alive, and just continue on. So you can actually do an interval with a current as well. If you want to just have the agent, let's say, push all the current values every second, you can do it like this, with interval equals 1,000. At, of course, you can't. It doesn't make any sense, so you'll get a protocol error if you try to specify the at. And that'll be, again, the latest current values of that stream every single second. Now, this is actually a trick that's used with the MTConnect agent when you want to get real-time updates. And what this provides is basically, you say, this was actually, we used this when we did the machine-to-machine integration. We talked about that a little bit before, where we were connecting up a robot and a machine tool. And the robot and the machine tool want to know what each other are doing as it happens, with almost zero, with as fast as the agent can do it. And that's why you say interval equals 0 means when something changes, push that data and tell me without any delay at all. And we actually, the agent can propagate data within approximately 3 milliseconds. And even a slow, like 190 megahertz ARM processor, we're able to get it to less than 10 milliseconds between the point that the agent finds out something has happened and the time that you actually get that XML document saying something has happened. And usually when you do this, because it occurs so quickly, you'll want to say exactly the data that you're interested in. So here is an example where we specify interval equals 0. And what we want to do is we want to be able to react to the execution or the controller mode state changing within 0 milliseconds. So as quickly as possible when this occurs, we get that reaction. A lot of data is updating very quickly, like positions, feeds, and speeds, and everything else. So if you were to do this with the agent without actually specifying the type of events that you're interested in, what you'd find is just this flurry of very tiny little messages and a huge amount of data flowing at you, which would be almost unmanageable. We talked in the beginning a little bit about this concept of what we call high availability. High availability means that you can always recover from a failure at the application side. So basically, MTConnect provides the concept that if for some reason the application fails and the agent is still running, the application can always pick up exactly where it left off without even missing a single event. As long as it's still in the circular buffer, you never have to worry. So when you disconnect, let's say there's a network outage and you're collecting data from the agent, when the network comes back on, what you do is you connect up to the agent again, and you immediately ask for a current, or you can ask for a probe. And the probe will give you, again, that instance ID. Now, once you know that instance ID, you can check whether the agent itself is actually restarted or whether it's kept running. Once you get that instance ID, then if it hasn't changed, what you do is you say, just get me another set of samples from that exact point where I left off. So here, the last time we were getting data from the agent the next sequence number was number 25. We received all the way up to number 24. So when we reconnect, the instance ID is the same. We pick up from number 25 on. So we just continue on. We have never missed a single event in that whole series. So that's what we also are talking about when we say store and forward. The agent is storing all this data and forwarding it to us. That means that we have fault tolerance built into the protocol itself. If, let's say, this instance ID has changed, then what we do is we need to start again with a current and then do samples. That means that basically the agent died and restarted. This gives us a way to be able to detect. The instance ID gives a way to very easily detect whether the agent has failed and whether we can continue on and whether any data has been lost. If we get a protocol error when we try to continue, then we know, again, that we need to start from the beginning because we've fallen too far behind. We've been disconnected for too long. Now, we talked a lot about open source before, and again, I'm going to talk about it. There's implementations of the agent that's available for you to download, and they're right here on the GitHub account for MTConnect, so mtconnect.com. And CTP agent is a C++ version of the agent. We're actually going to be implementing the new version of the agent. So far, we've decided to do it in Node.js for all those who are JavaScript fans and Node fans. That will be going on over the next year or so. So if you want to even participate in that open source project, please get in touch with us because we'd love to have you help out. The agent implements all the protocols. So remember the adapters are just pushing data to the agent, and it provides the XML generation and the HTTP RESTful interface that we talked about. And there are implementations in things like Ruby, Python, C, C# for being able to consume this data from the MTConnect agent. So we talked about streaming data. You can get that handed to you in a very nice chunked format in any of these languages here. And we've also got JavaScript and Node.js versions and lots of other things. Any other languages that you want, please get in touch with us. We can probably whip something together for you so you can use it. Let's talk a little bit about the asset model. The assets are, again, this key value store. So we have keys here, which are unique identifiers, universal unique identifiers. You can request a single asset like that, or you can put semicolons in between them and request multiple assets on the same line. If you just say, give me assets, you can get all the assets from the newest to oldest. In the next version of the agent, you'll also be able to say, give me assets for a particular device, specific to a device. You can tell how many assets you want. So here we're saying we want 1,000. And you can say, give me only cutting tool type assets and give me the 1,000 of them. And we're going to be implementing assets for process. So basically all the steps to be able to make a part in a discrete manufacturing process. Assets also support what we call removal. So whenever assets are removed from the agent, you'll also get notified that the asset has been removed. And the assets, the type is cutting tool, and they're, if you want to see so normally when you do an assets request, all the removed assets will be filtered out for you. If you want to see an asset that has been removed, you can actually request it directly by its ID, or you can say, give me assets, but also include the removed assets. And since they're not actually removed, they're actually just marked as removed, you'll see in the header of the asset that the removed is equal to true. You'll get an event that tells you whenever an asset is removed. So you want to see the state of that asset just as it was removed, you can request it directly as well. Now, similar to events, assets also are put into what's called a circular buffer. So it'll always keep the latest N events or assets, and this is at present 1,000. So we'll push in 1,000 events, as you can see here, and then all this will be removed as it falls off that back end. We can actually, the standard doesn't say how many assets we require to store. So theoretically, you could put like a database in behind this thing and store billions of these things if you wanted to. Currently, they're stored in memory in the MTConnect C++ agent. So just for resource consumption, we only store a limited number of them, but you can store as many as you want. And in the next version of the MTConnect agent, we'll also be supporting multiple backends for persistence. Let's talk a little bit about adapters. Now, adapters, again, to review, they collect data from machine tools. Now, an adapter can either be directly embedded within the machine tool. It can have optional additional sensors associated with it. As well, we can also hook up what we call legacy adapter, which is collecting data, let's say, off the PLC, just 24-volt signals, and sending them up to the agent. You can also have sensors associated with that. Or we can do like a pure sensor-based MTConnect implementation where you're just collecting data like vibration and electrical and other types of data from the device. These adapters then pass information to the agent. You can also have what are called networked adapters. A networked adapter is an adapter that's talking to, let's say, a machine tool's proprietary protocol over, let's say, Focus or LSV2, and that's passing data to the agent in what we call the shutter protocol. So all these adapters are passing data to the agent in what we call shutter. It's a pipe-delimited key-value pair. Now, there's a protocol also between the agent and the adapter. So the adapters respond to what we call the ping-pong protocol, which is just a heartbeat. So one of the problems is the adapter ever, let's say, dies or goes out. I mean, the agent needs to be able to detect that so it can set all the data items to unavailable. The way it happens, basically, the agent sends what's called a star ping. Anything starting with a star in the first character is considered a command as part of the command protocol. And it sends, the adapter needs to respond with a star pong, and then it also sends back how often it wants to be updated. So in this case, every 10,000 milliseconds. This is always in milliseconds. This is telling the agent that the agent should send a ping every 10 seconds, and the adapter will respond as quickly as possible. The first element in the pipe is always a timestamp. It's always in UTC. We always use GMT. That allows us to very easily determine what the time is and not have to worry about things like time zone and other conversions, which get very complicated. So data is always sent over using UTC, and we can also do what's called relative time. So because there are some machine tools that don't really know what time it is and sensors which have no clock, we have this concept that they can either send off a delta in milliseconds, or we can send what the machine tool thinks is the current time, and the agent will automatically correct the time and set it to the real time using the clock skew that it detects. And then the events and samples are then sent as key value pairs. So here's a little example. So basically, you get a timestamp, a data item name, a first name, value, name, value, name, value, etc. This is all documented again with respect to the C++ agent, and this is your timestamp. You can see an example right there. Conditions, because they have multiple values, a level in native code, native severity, qualifier, and message, are sent on a single line. And basically, this is an example of a high temperature. So this is the name, the value, basically the warning, normal, fault, like we went over before, a native code, native severity, qualifier, and then the actual text. Messages also have a native code, like this right here, change insert message. And the other type that's sent on a single line are called time series. Now this allows you to compress multiple values into a single message, and the order of arguments name, the count, the rate that these were sampled at, if it's variable, and then the number of values. Sample rate is optional. And again, we have libraries to generate these in multiple different languages, C++, C#, Ruby, Python. And again, if you want any other languages, please tell us. And that brings us to the last thing. So where do you get all these free tools? So here we have the MTConnect GitHub repo. So everybody should be familiar, hopefully, with GitHub. It's a wonderful source management system that's open, and this is all free to access. So go ahead and check it out. The agent, we have pre-built binaries for Windows and instructions on how to build it in Linux and other operating systems. It has been cross-compiled to almost all operating systems, so any Starnix, so Linux, BSD, OS 10, etc. are usable. As well, you should be able to download it and build it even for the Windows platform if you want to, and you can play around with it, and we'd love to have people contribute, so if you want to get involved, please do. Next thing is we have adapter labs and application labs, which are in C#, using what we call the .NET SDK. It's actually been used by many different companies to develop their MTConnect agents, so it's fully production quality. And you can play around with that if you want to develop your own adapter to do things like sensor data collection. We have a full application lab for you to play around with too, also in C#, and that uses the streaming API, and it's got examples of doing everything, even time series data and cutting tool data. The time series is getting waveform and 8 kilohertz streaming data coming over XML. Surprisingly enough, it does work. And the adapter lab sends that data in. The application lab actually plays it back, so it plays back audio that's collected over your computer. We have, we're going to be releasing an Android adapter for MTConnect. As well, there's, I think there's even, there's an Android client that was developed by Itamco, as well as Josh has also implemented a Google Glass demo and a Unity 3D demo for the Xbox. We have the MTConnect demo application, which is written in Ruby on Rails. That's available as well. And you can see it running at demo.mtconnect.org, and that provides a little bit of some very basic utilization analytics. So if you want to see how that's done with MTConnect, you can see that. It uses also streaming data. We have the robot demo that we were talking about before with the ROS and MTConnect integration using ROS Industrial, and that's also up there. And we have, again, the stream parsing libraries in all these different languages, so feel free to use any of this stuff. It's all released under the Apache 2 license, so free, open, and redistributable. If you want some other resources for doing data analytics, we would suggest checking out RStudio. This is for machine learning and such, and it's available here. There's a nice little IDE demo there on Vimeo that tells you how to get started with that. There's also some great IoT platforms that have emerged. Microsoft has one for machine learning, and so does Amazon. So if you want to check those out, please do. They also have now these complete IoT platforms which integrate some of these machine learning technologies as well as provide really good tutorials. They both have free levels to get started. So you can just connect up and play around, and it all works. We're also System Insights has released some R scripts for working with MTConnect data as well, and this is our GitHub repo, so you can check that out as well. So if you want to just take some MTConnect data off an MTConnect agent, stuff it into R, and then do some analytics, we have some technology for you to start playing around with that. So to get started, collect data using MTConnect. There's some public MTConnect agents that are running continually on the MTConnect on the internet. So you can just start streaming data, start pulling it in, as we showed in this webinar. start out with the probe, current, and then sample, and then start taking that data. Once you get the data, you can pile it into your own application, or you can import it into R and convert it into CSV data, and then start seeing what you can find. The idea is, again, as we went over in the beginning, focus on analytics and how to add value to manufacturing processes. And we are creating these webinars right now. So these slides are from a workshop that we did, and these are the results of those workshops. So that's
so Will,
pretty much
when
all I have
you
for
say you're doing those, Will, you said you're doing these webinars, they're being done at your facility, right? I mean, these, are they videos, or are they going to be live webinars?
We're going to be doing additional webinars. Yeah, they're going to be done at our facility. The first set are, well, these are actually the first set that we've been doing here as these live webinars. The next set will be diving deeper into things like analytics. So what we were just talking about, like how to use R with the AWS machine learning platform. We'll be doing one on that. We'll also, we're working on a webinar using the Azure cloud as well. So we're working on a couple of different flavors of webinar where we're going to be able to show you how to quickly get started with MTConnect data, how easy it is to use, and the power of using a semantic model for doing analytics, and how to turn that directly into wild and wonderful things you can do with data.
Great. Great. Well, it sounds like, I mean, besides these, you know, this, like we said, this is the 4th webinar of this series, and that's available now, and then going to get a lot more information as we go here. So that's good. And let's see. All right. So let me pull up. Let me bring this back here, because I think that was the last slide on that, right?
Yeah, that was.
Yep.
Those are in.
Okay. So Elena, you can come back in too. We have Elena. You want to talk a little bit about the these two websites? One is for the ideas, one is for the apps. I assume these are both deal with the challenge, right?
That's correct, Steve. The first one, the one that ends with ideas, is for the ideation competition. And the one that ends with apps is for the application development competition.
Okay. Catch you off guard there?
I guess
I have a cold. I know. You know what? I have that cough, and it's crazy. It's absolutely crazy. So, we've got, and if you have any more questions right now, then what our suggestion is to contact Elena, and she will get back to you, whether you have questions about the challenge or just questions about MTConnect in general. She'll be able to put you in touch with that. I mean, and I know you touched on it a little bit at the beginning, but again, tell us where the financial assistance is coming from for this, because we want to make sure we definitely recognize who the sponsors are.
Yes, the sponsor of the MTConnect Student Challenge is the Office of Secretary of Defense, Defense-Wide Manufacturing Science and Technology Program. Steve, you didn't ask this, but I'll go ahead and tell you that a number of organizations are coming together to plan and execute these competitions. Those organizations are AMT, the Association for Manufacturing Technology, MTConnect Institute, U.S. Army B'nai Labs, and CDMM, which is the National Center for Defense Manufacturing and Machining. And we're working in partnership with SME, Society of Manufacturing Engineers, and NTMA, National Tooling and Machining Association.
Okay. Were there any other questions that I should be asking right now, or is everything else pretty much available online?
Steve, we've made the frequently asked questions available on the respective websites, on the 2 websites you showed prior to this slide.
Okay. And this Facebook page is also about MTConnect, and you can also ask questions on there as well.
Yeah.
Correct? Okay, good. Well, so all right. So I think that we're at the end of this series, which is it's very in depth, a lot of information, and I know Will is like I say, godfather of MTConnect right there, and he has actually he has Star Wars tickets that he has to get ready to go to right now. So
Is that
I'm
right?
insanely jealous.
The important things.
So with that, I'm gonna say sayonara for the end of the webinar number 4, and you will be getting a lot more information very soon from Will and Helena, and who knows, somebody else too. So thanks again for joining us, Will and Helena, this morning, and we will see you again on the internet. Last words of wisdom before I cut you guys off.
Please join. Please submit. And thanks so much, Steve, for being our gracious host.
Gracious is a word that lots of people use about me. So.
Thank you, Steve.
All right. So thanks again, you guys. This is Steve Miller, better known as Kelly's dad, marketing gunslinger, and I will see you somewhere on the internet. Bye, everybody.
See you later.
Take care.